That faint smudge in the sky is Andromeda. It's 2.5 million light-years away, but racing toward us at 110 kilometers per second. You might wonder how this is possible when dark energy is constantly stretching the universe apart. For nearby galaxies, local gravity simply overpowers that expansion, reeling them in. In 4 billion years, gravity will win this cosmic tug-of-war, and these two massive bodies will inevitably meet. The sheer volume of material is difficult to comprehend. The Milky Way carries around 250 billion stars, and they are about to plow head-on into the over 1 trillion stars housed inside Andromeda. When we hear the word collision, we immediately picture chaos. We imagine massive planets smashing together and suns shattering like glass into a debris field. So what actually happens when over 1 trillion heavy celestial bodies try to occupy the exact same space at the exact same time? And could our solar system survive the impact? To understand the physical mechanics of this event, we must scale down from the entire galaxy and look at the actual neighborhood around an individual star. While over 1 trillion stars are involved in this merger, they are separated by incomprehensible expanses of empty space. Because of this vast spacing, the statistical probability of 2 stars physically touching is virtually zero. They simply glide right past one another. The event functions as an optical illusion. 2 diffuse, ghostly clouds of light pass through one another in silence, their stars missing each other in the dark. But dodging a direct hit does not mean escaping unharmed. While the stars won't crash, their orbital paths will be completely derailed by the sudden influx of competing gravity. The 2 organized spirals will break down, tangling and collapsing into a dense elliptical supergalaxy called Milkdromeda. As gravitational fields warp, our solar system is caught in the churn and violently whipped outward toward the extreme edge of this new web. We will be pushed into a true galactic Siberia. The solar system could be flung up to 160,000 light-years away from the new center of Milkdromeda. The Sun and its planets survive the merger physically intact, but our solar system loses its old neighborhood. We become a lonely coordinate in the far reaches of the galactic suburbs. While the outer edges of the galaxy experience a quiet relocation, the situation is drastically different at the heavy, dense center. This is where the true violence occurs. Both supermassive black holes at the galactic cores will relentlessly spiral toward one another. To complicate the gravitational chaos even further, a third body, the smaller Triangulum satellite galaxy, is projected to join the fray, adding its mass to the churning center. Eventually, the supermassive black holes will close the distance and fuse together, creating a massive gravitational well that instantly begins consuming surrounding stellar gas. All that feeding gas will superheat, igniting a brilliantly bright quasar right at the very center of Milkdromeda. So while the outer perimeter of stars simply ghosts past one another in silence, the newly formed core will host the most energetic gravitational event in our local universe. If you could stand on Earth and look up, the familiar Milky band of stars we see today would be completely gone. In its place, the night sky would be set ablaze by a blinding elliptical core and the piercing glow of that distant quasar. But before we worry about the view, we have to look back at the actual timeline. This entire light show is still 4 billion years away. This 4 billion-year timeline reveals a more immediate reality closer to home. Long before Andromeda reaches us, a different cosmic clock will run out. Long before Andromeda arrives, our sun will reach the end of its life, swelling into a red giant and incinerating our planet. The universe operates on a scale of time so vast that our greatest imagined cosmic threats are often entirely secondary. Long before the galaxy falls apart, we will quietly succumb to the natural life cycle